Something is shifting inside the personal computer industry. It is not loud. It is not a single announcement or a dramatic product launch. It is a quieter, more deliberate kind of change, the kind that only becomes visible when you step back and look at the full picture of what the world's largest PC manufacturers are doing, and more importantly, what they are preparing for. For decades, the relationship between PC makers and Microsoft Windows was one of the most stable partnerships in the technology industry. You bought a computer, it ran Windows. That was simply how personal computing worked for the vast majority of people on Earth. But that certainty is beginning to fracture, not because Windows has failed and not because any single competitor has defeated it, but because the ground beneath the entire PC industry is moving. Artificial intelligence, new processor architectures, cloud-first computing, and fundamentally changing user expectations are forcing companies like Dell, HP, Lenovo, Samsung, and Asus to think about the operating system question in ways they have not had to think about it in a generation. This is the story of why that is happening, what it means for the machines you use every day, and whether the era of Windows as the automatic, unquestioned default for personal computing is genuinely approaching a turning point. To understand why the current moment feels significant, you first have to understand how complete Windows dominance has been, and for how long. In 1981, Microsoft signed what would become one of the most consequential business agreements in the history of technology. IBM needed an operating system for its new personal computer. Microsoft, at the time a relatively small software company, licensed an operating system, refined it, and delivered it. Crucially, Microsoft retained the rights to license that operating system to other manufacturers. IBM agreed, almost certainly without fully anticipating the implications of that decision. What followed was the rise of the IBM-compatible PC ecosystem, a sprawling, competitive market of hardware manufacturers, all building machines that ran Microsoft's operating system. The result was a self-reinforcing cycle of extraordinary power. More hardware manufacturers meant more Windows machines sold. More Windows machines meant more software developers writing for Windows. More Windows software meant more users choosing Windows-compatible hardware. The cycle fed itself for decades. By the time the personal computer became a mainstream consumer product in the 1990s, Windows was not simply the leading operating system. It was, for most practical purposes, synonymous with personal computing. Apple maintained a loyal and creatively significant following with the Macintosh, but its market share remained a fraction of Windows. The OEM relationship, original equipment manufacturer, meaning companies that build hardware and install an operating system for sale to consumers and businesses, became the backbone of the PC industry's economics. Microsoft earned licensing revenue from every Windows machine sold. PC makers benefited from offering software compatibility with the world's largest application ecosystem. Enterprise customers chose Windows because their IT infrastructure, their line of business applications, and their employee familiarity were all built around it. This arrangement was mutually beneficial, commercially durable, and genuinely difficult to disrupt. The applications ran on Windows. The businesses ran on Windows. The schools taught on Windows. The homes functioned on Windows. Through the transition from command line interfaces to graphical interfaces, through the rise of the internet, through the era of portable laptops and ultrabooks, Windows adapted and retained its position. When Microsoft stumbled, and it did stumble significantly with Windows Vista, with Windows 8, with the failed mobile strategy of the early smartphone era, the OEM ecosystem largely absorbed the turbulence and continued. The question that now demands examination is whether the structural foundations of that dominance remain as solid as they once appeared. The answer to that question requires looking at several converging forces simultaneously, because no single development is responsible for what is happening. It is the combination that matters. The first, and perhaps most immediately visible force, is the rise of the ARM processor architecture in personal computers. For the majority of the PC industry's history, processors in Windows machines were built on the x86 architecture, developed by Intel and later extended by AMD. This architecture was powerful, broadly compatible, and deeply embedded in the software ecosystem. Windows itself was built and optimized for x86 hardware. Then, in 2020, Apple released the M1 chip, an ARM-based processor of its own design in its Mac computers. The performance and efficiency results were genuinely striking. The M1 delivered processing speeds that competed with high-end Intel processors while consuming dramatically less power, which translated into longer battery life. Subsequent generations, the M2, M3, and M4, extended those advantages further. The PC industry took notice. Qualcomm, which had been developing ARM-based processors for Windows devices for several years with limited success, continued refining its Snapdragon X series chips. By 2024, Snapdragon X Elite and Snapdragon X Plus processors were being featured in a new category of Windows devices marketed as Copilot Plus PCs. These machines offered ARM architecture efficiency gains and dedicated neural processing units, hardware specifically designed to accelerate artificial intelligence workloads locally on the device. The ARM transition creates complexity for the PC ecosystem. Not all existing Windows software runs natively on ARM architecture. Microsoft has built an emulation layer that allows x86 applications to run on ARM-based Windows machines, and that emulation has improved considerably. But it introduces performance overhead and compatibility considerations that manufacturers must communicate to customers. The transition is real and ongoing, but it is not seamless, and any honest analysis must acknowledge that. The second major force is Chrome OS and its sustained relevance in the education market. Google's Chrome OS, which powers Chromebook devices, had a remarkable run through the 2010s in the education sector, particularly in the United States. Schools found in Chromebooks a combination of low cost, simple management, fast startup times, and automatic updates that made them attractive for classroom deployment. For students whose primary computing needs were web-based, Google Docs, educational web applications, video conferencing, Chromebooks were more than adequate. PC manufacturers, including HP, Lenovo, Asus, and Samsung, all built Chromebook product lines. These were not Windows machines. They were deliberate, commercially meaningful investments in an alternative platform. The education market insights mattered because education shapes long-term computing habits. Students who grow up using Chrome OS are a different kind of future customer than those who grow up on Windows. The third force is Linux adoption in specific market contexts. Linux has long been the operating system of servers, supercomputers, and embedded systems. On the desktop, it has historically struggled to achieve mainstream adoption despite its technical merits. However, there are meaningful pockets where Linux has gained serious traction. Dell's XPS Developer Edition line ships with Ubuntu Linux pre-installed, targeting software engineers and developers who prefer a Unix-like environment. System 76 builds machines specifically designed for Linux users. In certain government and enterprise contexts in Europe and Asia, Linux deployments have been driven by data sovereignty concerns and the desire to reduce dependence on American software vendors. These are not mass market shifts. Linux desktop market share remains small in percentage terms globally, but the willingness of major manufacturers to invest in Linux-configured hardware represents a genuine diversification that would have seemed unlikely to many analysts a decade ago. The fourth force, and arguably the most structurally significant, is the shift toward cloud-first and AI-native computing. Cloud computing has progressively moved computing workloads off the local machine and onto remote servers. For a growing segment of users, the local operating system is primarily a portal to cloud-based services. Microsoft 365, Google Workspace, Salesforce, Adobe Creative Cloud. The capabilities of the local hardware and operating system matter less when the application logic, the data storage, and the processing are all happening elsewhere. This shift creates a question that PC manufacturers are actively grappling with. If the local operating system is primarily a browser and a portal to cloud services, what exactly is the value of the Windows license fee in that equation? The question is not rhetorical. It is a commercial calculation being made in executive meetings at major hardware companies. Artificial intelligence adds another layer. The emergence of large language models, on-device AI inference, and AI-powered productivity tools is creating demand for hardware with dedicated AI processing capabilities, neural processing units built into the chip. Microsoft has positioned Windows 11 with its Copilot integration as the platform for this AI PC era. But the AI workloads themselves do not inherently require Windows. They require capable hardware and well-integrated software, which multiple platforms can potentially provide. Understanding that these forces exist is one thing. Understanding why they are compelling PC manufacturers to actually change their strategies requires looking at the specific pressures those companies face. The enterprise market, which represents an enormous share of PC revenue, is evolving its requirements. Chief information officers and IT departments are under pressure to reduce total cost of ownership, improve security posture, simplify device management, and support hybrid work models. The proliferation of mobile device management platforms, zero-trust security architectures, and cloud-based IT infrastructure has made the operating system somewhat more interchangeable in enterprise context than it was when line-of-business applications had to run locally on Windows. Battery life and thermal efficiency have become significant competitive differentiators in the premium laptop market. As consumers increasingly use laptops without regular access to power outlets, the gap in battery performance between ARM-based machines and traditional x86 machines has become commercially meaningful. If Qualcomm's Snapdragon X processors can deliver genuine all-day battery life in a thin, light device, manufacturers have a commercial incentive to build and market those devices prominently, regardless of the operating system complications they introduce. Cost structure is another pressure. Windows licensing fees represent a component of the bill of materials for every Windows PC. In the budget and education segments, where margins are already thin, the ability to sell a device without a Windows license, as is the case with Chromebooks or certain Linux configurations, provides meaningful pricing flexibility. This is not a new dynamic, but the availability of genuinely capable alternative platforms has made it more relevant. The AI workload question is creating hardware differentiation opportunities that manufacturers are eager to exploit. If a PC can run AI models locally, generating text, processing images, transcribing speech, without sending data to a cloud server, that represents a genuine value proposition for enterprise customers concerned about data privacy, and for consumers who want capable AI tools without recurring subscription costs. Building devices optimized for these workloads requires integrating neural processing units, which is happening across ARM-based Windows devices, certain AMD and Intel processors, and in Apple's Silicon lineup. The operating system is a participant in this transition, but the hardware innovation is the primary driver. Global market dynamics also play a role. In Asia and in parts of Europe, government procurement preferences, data localization requirements, and strategic technology policies have created institutional incentives to reduce dependence on Windows specifically and American software ecosystems more broadly. Chinese PC manufacturers have invested in domestic operating systems. Several European government bodies have explored or implemented transitions to Linux-based environments. These are not dominant trends, but they are real, documented, and commercially relevant for manufacturers who serve global markets. The competitive landscape is reshaping PC makers' thinking, not because any single alternative to Windows has achieved critical mass, but because the combination of alternatives has made the operating system layer genuinely contested in a way it has not been since the early 1990s. Microsoft is not a passive observer in this transition. The company's response to the pressures reshaping the PC industry is substantive, strategically coherent, and worth examining carefully. Windows 11, released in 2021, represented Microsoft's attempt to modernize the Windows platform for a new era. The redesigned interface, improved performance on modern hardware, enhanced security architecture, and tighter integration with Microsoft's cloud services were all meaningful improvements over Windows 10. The system requirements controversy, Windows 11 required a trusted platform module chip and relatively recent processors, effectively excluding older hardware, generated significant backlash, but also reflected a deliberate choice to build the platform on a more secure and consistent hardware foundation. The Copilot integration represents Microsoft's most ambitious attempt to position Windows at the center of the AI computing era. Copilot, powered by technology built in collaboration with OpenAI, is embedded directly into Windows 11, offering AI-assisted productivity features accessible from the taskbar and integrated across Microsoft 365 applications. The vision Microsoft is articulating is of Windows as the operating system that makes AI genuinely useful in everyday computing, not through a web browser or a cloud subscription alone, but through deep integration with the local hardware and operating system. The Copilot Plus PC initiative, launched in 2024, marked a further step in this direction. These devices, defined by the presence of a neural processing unit capable of at least 40 trillion operations per second, were positioned as a new category of AI-native personal computers. Features like Recall, which was designed to create a searchable timeline of everything you had done on your PC, generated significant privacy controversy and were delayed pending further development. That controversy itself illustrated the sensitivity of the territory Microsoft is navigating as it attempts to make Windows more intelligent. Microsoft's investment in ARM-based Windows is also significant. The company has worked with Qualcomm to improve both performance and application compatibility on ARM hardware, and it has made its own first-party applications natively compatible with ARM architecture. The emulation layer for x86 applications has improved to the point where many common applications run acceptably, though gaming and certain professional applications remain areas where ARM-based Windows devices face limitations. On the cloud side, Microsoft's Azure infrastructure, Microsoft 365 subscription services, and the deep integration between Windows and OneDrive represent a coherent ecosystem strategy. Microsoft is not simply defending Windows as a product. It is defending Windows as the entry point to a cloud and AI ecosystem that generates substantial and growing subscription revenue. The Windows license fee is in some ways less important to Microsoft's financial model today than it was 2 decades ago. The recurring revenue from Microsoft 365, Azure, and enterprise services has grown to represent a dominant share of the company's income. This is a commercially sophisticated position. Even if the PC market diversifies and Windows' share of devices declines at the margin, Microsoft's revenue can remain resilient if its cloud and AI services remain central to how businesses and consumers operate, regardless of which operating system those users are running. The question of what the PC looks like in a decade from now resists simple answers. The honest assessment is that the future belongs not to any single platform, but to a more fragmented, more diverse, and ultimately more interesting landscape than the Windows monoculture of the 1990s and 2000s. Windows will almost certainly remain the dominant operating system for enterprise computing for the foreseeable future. The depth of Windows integration in corporate IT infrastructure, the breadth of enterprise software written for the Windows platform, and the familiarity of the global business workforce with Windows make a rapid displacement essentially implausible. What is more plausible is a gradual erosion at the edges, in education, in emerging markets, in specific enterprise contexts where cloud-first architectures reduce platform dependency. Chrome OS will continue to be relevant in education and potentially expand into enterprise contexts where web-based workflows dominate. Google has invested in making Chrome OS more capable, adding the ability to run Android applications and, in certain configurations, Linux applications. The line between Chrome OS and a full-featured operating system is narrowing. Linux on the desktop will remain a minority platform globally, but may continue growing in developer and enterprise niche contexts. The Steam Deck gaming handheld, which runs a Linux-based operating system called SteamOS, has demonstrated that Linux can provide a consumer-grade gaming experience, a domain where it was previously considered entirely uncompetitive. Apple's macOS, powered by the M-series Silicon, will continue to attract premium users, particularly in creative and professional fields, and will maintain the competitive pressure on Windows that it has generated since the M1's debut. The wild card in all of this is artificial intelligence. If AI development produces genuinely capable AI-native operating systems, environments built from the ground up around natural language interaction, contextual awareness, and on-device intelligence, the relevance of traditional operating system categories may diminish in ways that are difficult to predict with precision. Several technology companies, including startups and established players, are exploring what it would mean to build an operating system that understands user intent rather than waiting for explicit commands. Whether those efforts produce commercially viable products within the decade is uncertain. That they are being pursued is not. The personal computer industry is entering a period of transition that most analysts agree will be among the most consequential since the rise of the internet. For the better part of 4 decades, the question of which operating system ran on a personal computer was answered before most users ever thought to ask it. Windows was the default. It was the assumption baked into the manufacturing decision, the retail shelf, the enterprise purchasing order, and the classroom deployment. That assumption is not broken, but it is being examined in ways it has not been examined in a long time. By hardware engineers designing new processor architectures, by enterprise IT directors rethinking their procurement strategies, by education administrators weighing the cost and capability of competing platforms, and by consumers who have begun to notice that the operating system on their device is one choice among several, rather than an inevitability. The PC makers rethinking their relationship with Windows are not abandoning it. They are doing what competitive, commercially rational companies do when the landscape shifts. They are hedging, diversifying, and positioning themselves to serve customers whose needs are evolving in multiple directions simultaneously. For users, the practical implication is the possibility of more genuine choice than the industry has offered in decades. More platforms, more form factors, more configurations designed for specific use cases rather than one-size-fits-all defaults. But perhaps the most profound implication lies further ahead. Because the operating system debate, Windows versus Chrome OS versus Linux versus Mac OS, may itself be a transitional conversation, a placeholder discussion for the period between the computing era we have known and the one that is still taking shape. The next generation of computers may not be defined by which operating system they run. They may be defined by how intelligently they understand and anticipate the person using them.